videos. And I'm gonna say Simpson because I can't tell if that's, is your video on or not? Okay, just want to make sure. All right, because I do have some students, that's why I make sure the video's on. They just turn on the video and then they leave or go do something, and then at the end of the class, so that's why I have to make sure the video's on. So, all right. Now, 4.1 and 4.2 is a quick chapter. And the chapter is quick because it's not a lot of things that you've never seen before, okay? Stuff you've seen before except a few definitions. So we're going to go over it pretty quick. This one class is pretty much going to go over everything. And after you see why I'm going over, you'll say, oh, I see why. All right, so there's 3 or 4 things that 4.1 and 4.2 goes over. 4.1 and 4.2 cover the following things. Number 1, correlation or scatter plot. A scatter plot is basically a graph of points. You do not connect them, you just plot them. And you look for a pattern. And number 2, the pattern is going to be called correlation. And both of these pens go in the trash can. And I'm going to grab 2 more. Correlation is basically, do you see a pattern? Correlation is a number between -1 and +1. Is that a test question? Yes. Usually you can see this with the line of best fit, or what some people call line of regression. I will be showing you how to do this with the Excel spreadsheet or your calculator. Causality. Causality is not mathematical. Causality uses a little bit of common what?
Sense.
Common sense. And I always spell sense with an S. Is that right? I can't.
Yeah, it is.
I always want to spell it with a C. Common sense. And then 4, slope, and find an equation. And that you will do by hand. Now that is the 4 things that you will be tested on in 4.1 and 4.2. So let's go ahead, and I'm going to just show you everything pretty much on the spreadsheet, and the first 3 or the first 2 we're going to talk about on the TI and Excel. And that's not a number, this is R. I keep forgetting to put R. R is called the correlation coefficient. So make sure you make that note. R is between -1 and +1. And there's one more thing about the correlation coefficient that is a test question. And here's the test question. The relationship between the correlation coefficient and slope is both of them are positive and negative. Slope / correlation coefficient. The slope, if the slope is positive, the correlation coefficient is going to be positive. If the slope is negative, the correlation coefficient is going to be negative. That is a test question. It's basically, what is the relationship between slope and correlation? And you would say negative, negative, positive, positive. If the slope is negative, the correlation coefficient is negative. If the correlation coefficient is positive, the slope is positive. That's the relationship between slope and the correlation coefficient. All right. So let's go. And I want you to get your calculators out. And I'm going to go to the Excel spreadsheet. So if you would get your calculators out. Y'all do have calculators, right?
No, sir.
Y'all don't?
Not today.
The teacher who's in here with us usually isn't here, so she can't give us our calculator.
Oh, so you don't have your calculators that you use in class?
No, sir.
Okay. Well, what about, can you use the spreadsheets?
We're
Can you
on,
use your spreadsheets?
we
Yeah.
can kind of.
Yeah, we can
Okay.
be.
All right, well, just watch, okay? And you can watch the video and rewind or do whatever you need to do for the 1 or 2 people that actually watch the videos. All right, so let me make this a little bit bigger. And make this aerial. And we're going to make this, hopefully y'all can see all the borders. Is that good? Can everybody see that real good? Pretty much? Everybody, give me a thumbs up. Okay. All right, so I'm just going to put some numbers up here. 2, 4, 6. Write these in your notebooks. 2, 4, 6, 8, 10, 11, 12, 15. And 1, 2, 5, 7, 9, 3, 4, 10. All right. Now, they're going to give you some form, some fashion, a table like this. They're going to say, we want to see a scatter plot. So let's go ahead and pull up my handy dandy calculator and stat. Let me get this big enough to where y'all can see it. Can everybody see my screen okay? Can you see the calculator in the spreadsheet? Okay. Please stop me if you have any questions. And I've come to realize if I keep talking, I won't hear that annoying noise. So I'm just going to keep talking unless you got a question. All right. So stat, edit, and there's my numbers: 2, 4, 6, 8, 10, 11, 12, 15. And 1, 2, 5, 7, 9, 3, 4, and 10. So I've got them in both. And the homework or the test is going to want you to draw a scatter plot. So A, we're going to draw a scatter plot with the Excel spreadsheet. You highlight the 2 columns. You hit insert. and you click on the charts and you pick the first one, which is a scatter plot, and that's what it looks like. So if you want to kind of draw a sketch of that in your notes so you can see what's going on. Now, my job is not to connect the dots. My job as a math teacher or a math student or as a statistician or as somebody presenting is to draw a line that best fits those points. Like through there, if I could draw a straight line. Hold on a minute. That line sucks. I have to switch between whiteboards. Here we go. I think this is the white one. Yeah, the right one. And I would say probably the line looking like that. Okay, everybody see that? Needs to be extended right here, but I'm not going to worry about it. See, right about, I'd say probably right in there. Now I just did that just by eyesight. Okay. Now this is the way you do it with your Excel spreadsheet. Right click on one of the dots. That noise is so annoying. Right click on one of the dots. And hit add trend line. And see, mine's a little bit off. And hit display and display. And there is your line of regression in r squared, which we really don't care about. So we're going to take r squared and we're going to find the, I'm going to do that over here, r, find the correlation coefficient, square root of r squared. So that's going to be 0.4748 raised to the 0.5 power. So R is equal to, and I'm going to try to write this without screwing it up. Well, that ain't going to work. Give me a second to change this. R is equal. My mouse does not work well with this whiteboard. R is equal to 0.69. Oh, me. Damn Russians. There we go. 0.69. Now, thank y'all for being patient. This whiteboard and my mouse don't work good together. So, all right. So, and I'm going to erase this line right here because we don't need it, because that was my eyeball. So there is your line of regression. So does anybody have a question on how to get that? As far as, I'll do another one in just a minute. So y is equal to 0.5189 x plus 0.714, and the correlation coefficient is equal to 0.69. So would you say that's a strong correlation? Well, it's close to 9. It's close to 1. So yes, that is a strong correlation. Anything above 0.5 or negative 0.5 is a strong correlation. And if you read 4.1 and 4.2, I'll show you that in just a minute. You will see how to tell if something is a strong correlation. All right, any questions on that? Let's go to the TI. Now, before you start the TI, before you work your TI, I want you to check something when you do your TI. All right, I want you to write down second 0, and that's catalog. Second 0, and I want you to go down to the D's. You're looking for diagnostic on. Does everybody see that right there?
Yes, sir.
This is a one-time thing that you have to do to your calculator. So after you do it the first time, unless somebody turns it off, you don't have to do it again. Go to make sure your cursor is beside diagnostic on and hit enter and hit enter. Now I'll show you what that does in just a second. Now go to stat, calculate, and you go down to linear regression. It's going to automatically read L1 and L2, and all you have to do is hit calculate. There is, they say y is equal to ax plus b. So you just take your handy dandy, you just go y is equal 0.5189 ... x plus 0.7140. Same thing as we got with Excel. And R is equal to 0.689 or 0.69. Now, make a note here. If you don't see R squared, and this is a red pen, so I'm writing this down because some of y'all are going to come to class with the calculator and say, I couldn't find R squared and R. Well, you didn't listen. R squared or R does not show up. You have to go to second catalog or second 0, go to diagnostic on and hit enter and enter. That right there, when you turn the diagnostic on, it will show R squared and R on your calculator. So if you don't see R squared or R, that means you got to turn on the diagnostic. All right, let's do another problem. Now remember, you will use the Excel spreadsheet or your calculator on the test on these. I'm not going to ask you to do this by hand. It takes too long and it's too tedious. You're welcome. All right. Let's do another one. Let's go over here. Let me delete this. Delete. As soon as I can delete it. And let's change these numbers. Let's go with 0, 1, 2, 5, 7, 11, 12, and 15. 2, 2, 4, 5, 7, 8, 9, 3, 2, 1. Okay, no 1. All right. So at this point, I'm going to go to my handy dandy calculator. And I'm going to type them in, edit, 0, 1, 2, 5, 7, 11, 12, and 15. 2, 4, 5, 7, 8, 9, 3, 2. Why didn't it? Oh, God. 2, 4, 8, 9, 3, and 2. And let's go ahead and do it on the calculator first. Go to Stat, Edit, or Calculate, Linear Regression. Defaults to L1 and L2, so you just hit Calculate. So that means with our, Y is equal to 0.0229x plus 4.848. And R is equal to 0.05, which is a very weak correlation because it's close to 0. Okay, so there's a very weak correlation. Probably talking about a line looking something like this, right near being horizontal. So let's look at the graph and see what it says. So I'm going to show you how to stat plot. This is how you stat plot on your calculator. Hit second, Y is equal. Hit enter. Hit enter again to turn on the stat plot. It automatically defaults to a scatter plot, and it automatically reads L1 and L2. So all you have to hit now is graph. And I need to turn off my Y is equal, sorry. Clear. And I hope y'all understand what's going on. Nobody's asking questions, so. And if you can't see the graph, you hit zoom and 9. And now you put in your Y is equal to, and type in your graph, your regression line, 0.0229x plus 4.848. And that is your line of regression. So what if we just went over? We just went over following things. We just went over scatter plot, and we went over correlation, and we'll go over this a little bit more. So let's go ahead and go to the book now and see what they've got on it, because I don't want to go into causality yet. So let's go to the book. Oh, sorry. Highlight, insert, chart. Make it big enough so y'all can see it. right click on one of the circles, dots, add trend line, go down and hit display and display. And let's see if they match up with what. Is that what we got? Let's see, where is my sheet? There it is. So is that what we got? 0.229x plus 4.848. And I got you take the square root of 0.0022. Well, let's do that. 0.0022. 0.022. 0.05. And I think that's what we got. Yep. Question on scatter plot or correlation. Now I'm going to write something down for you that's going to be in your homework, and it's going to be on the test. So make sure you write this down, please. They're going to ask you to look up in a table and compare your correlation coefficients. All you have to remember is this. If your correlation, the absolute value of your calculated correlation, absolute value of your calculated correlation is greater than the table correlation. Okay, write that down. If the calculated correlation, what you get on your TI/Excel spreadsheet, R, it's not with two L's. If your R that you calculated is greater than the table correlation that you're going to look up, then there is a correlation. Now that could be negative or positive. If your correlation before you put in here is negative, that would be a strong negative correlation. If the correlation is positive before you put it in absolute value, then that would be a strong positive correlation. So if this right here, and it's in the book too, so I didn't make it up. If your absolute value of your calculated correlation is greater than your table correlation, there is a correlation. And we'll get into that when we do another problem. Now let's go to the book. Let's go to the book. You don't need to go to the book, but I'm going to go to the book and I'm going to pull up ebook. Well, I'm trying to find it. Chapter 4, 4.1. I'm going to go through and pick out what is important and what I just went over to make sure y'all understand what we're talking about. And for some reason, when I hit 4.1, it goes to 4.2. So I don't know why it does that. Let me go to the table of contents and hit 4.2, 4.1 again. Did that this morning in the 8 o'clock class. Yeah. All right. So their scatter plot's going to be on the next page probably. And there's a scatter plot. I'm not going to go over that too much, but that's a scatter plot. Okay, write these down right here. I'm going to blow them up for you. These are test questions, standardized test questions, as well as my test. And I just hit the wrong button again. Make sure you write those down. That's a linear positive correlation, a linear negative correlation, a nonlinear, you don't have to draw the nonlinears, and no relation. Now you will be tested on the linear A, linear B, and nonlinear in this test. So you don't have to write down the nonlinears because just for your information, you might see them on a standardized test. Okay. So make sure you know what this one looks like, this one looks like, and this one looks like. Next. This is the, and I'm going to show you this. You can write it down if you want to. This is the math behind finding R. And I think you can see that you don't want to do that math. So I think you should say, thank you, Hubert, for me not making you do that math. But if you want it, there it is. There, I'm not even going to do it. And it's not difficult, but there's the other. It's just tedious, and there's no sense in you having to do that.
Right.
Now, if you were in a research class, then I might make you do that, but not for an introductory level course. Okay, there's your scale again, -1 to +1. I already told you that. Here is some more examples. I want you to write those down and just kind of sketch them. You don't need to worry about the nonlinears. Just the first four: B, C, D, and F, and G, but not the nonlinear. So just draw a sketch. Now some of y'all aren't writing anything. I don't know why, but you need to draw a sketch of these. Just to let you know. I don't want to, don't come to me on the test and say, oh, I didn't understand the question, when all you had to do was write these down.
Someone's asking what page. What page is this on? What page is this on?
Okay, this is on page, well, I can't see the page. Hold on, let me. It's on page, well, 174. I'll give you another few seconds to write those down. And for the 1 or 2 people that watch the video, you can write them down and pause it. Okay. Let's see what else is on test agenda. This right here is just showing you how to see a pattern. I'm not going to go through that too much because most people know how to see a pattern. That's left to right up. That's how they compute the correlation coefficient. We're not going to do that. Here's some of your math right there. On page, whatever page that's on. Page 176 shows you how to find R by hand. And that's just a little bit too much. Okay, here's that rule I told you about right here on page 170. Oh, where is it? Well, the page number was there on the last page. Hold on a minute. Page 177. Page 177, here is the, and this is what's going to get you on the homework. If the absolute value of the calculated R, number 3, if the absolute value of the calculated coefficient is greater than the critical value, which is the table value, then a linear relation exists. Otherwise, no linear relation exists. So if you write anything down on this page, make sure you write down step 3. The absolute value of your calculated R, if it's greater than the critical value, which is the table the table correlation coefficient or the critical value, then a pattern exists or a relationship exists, correlation. Otherwise, no correlation exists. And they even put it to you right here in the margin about absolute value. So okay, that's 4.1. 4.2, causality, slope, and equations. Causality. Some of y'all are familiar with the movie The Matrix.
Yes.
In the second movie, they walk into the restaurant, the French restaurant. Does anybody know what I'm talking about? No, because it's not animated and it's not Marvel Comics, so y'all don't pay attention to it. All right.
Yeah. That's right. That's what it is.
Let me ask you something. Have y'all started tearing up the bathroom?
No.
Have you started tearing up the bathrooms? The iPod generation is now tearing up the bathrooms.
I think
You know, I told my son, he started West Side. I said, I feel sorry for you, Walt. He said, why? He said, because you got the dumbest ass generation there ever has been. And he looked at me, he said, what do you mean? I said, well, I'm in the 80s, and I've watched people in the 90s grow up, and I've watched people in the early 2000s grow up, and they do not hold a candle to how stupid this generation is. This has got to be, and I'm excluding y'all, of course, because I hope y'all don't go around just eating Tide Pods and messing up property. But this has got to be one of the stupidest generations I think I've ever seen. So I hope y'all agree with me. I mean, because tearing up restrooms is about stupid. Anyway, causality. I drink too much wine. I have to pee. Now, that is a quote. That is a quote from a movie. Now, why do I pick this quote from a movie? Because you'll remember it. I drink too much wine, I have to pee. What is causality? They say it in the movie too, in Matrix 2, they say it. What is causality? 2 words. Actually, 3 words.
Cause and effect.
Good job. Dang old country song. Cause and effect. Actually, it should be A. Cause and effect. Does everybody know what that means?
Yes.
That means one thing causes the other. You're not going to drink a bottle of wine and just sit there and go, okay. I mean, that's not going to happen. Or a jug or a big old container of water. You're going to have to go to the restroom.
Yeah, you break that
Cause and effect. Make sure you understand, because if I work, let's say I work at a movie theater, and I'm in a statistics class, and I'm gonna make this my project, and I'm gonna say, name a movie. So, well, I'm not gonna name. No, forget it, because all y'all. I'm gonna just name a movie. I'm on Halloween.
Cupid's Halloween.
The new one comes on October 15th.
Cupid's Halloween.
What?
It's a movie called Cupid's Halloween. Is that It is right.
All right. Okay. Thank you. All right. And here's the ticket sales for Halloween. And then I go, well, I'm going to go over to the AMED and I'm going to ask them how many people committed suicide in this week. Let's say this is October 15th through the 31st. And I go over to AMED and I say October 15 to 30 suicide rates. And it has a correlate. R is equal to 0.91 and R is equal to 0.93. Can I say that Halloween movies cause suicide?
No.
No.
Yes, you can. I mean, you can.
You can? Maybe if you eat Tide Pods, maybe. But you can't. This is correlation. This is correlation, and this is correlation. But does one cause the other?
No.
No. Therefore, causality equals correlation. But does correlation equal causality?
No.
No, it doesn't. So you need to write that down, because that's a test question. Causality means correlation, but correlation does not necessarily mean causality. if I drive to the beach, let's see, if I go to the beach and I just go by myself, I'll get 25 miles to the gallon. And then if I go to the beach and I carry 6 people with me with luggage, is my gas mileage going to go up or down? Is my gas mileage going to go up or down? It's going to go down.
How's that work?
Well, let me ask you a question. Let's say that you go on a 1 mile walk and you do it in 4 minutes. And then I put a 15-pound pack on your back. What? You figured it out?
Yeah.
What? What causes my gas mileage to go down?
The way
Stop.
Wait.
it's Monday with me alone.
Okay. So is this cause and effect? Yes. You cause and effect. You have to actually have some sentient common sense and ability. You have to have it. You cannot just say, oh, well, Halloween causes suicide. The movie Halloween causes suicide. You can't do that. So causality is when you can make an actual connection between 2 things happening. That volcano over in Africa, if it blows up, is that going to affect South Carolina?
No.
Oh, yeah. Dang old tsunami, dang old East Coast, dang old flood. Cause and effect. Oh, but you hadn't heard about that volcano, have you? Oh, that's real news. But you hear about masks and have to wear a mask and all that. But you don't hear about the volcano. All right. So now you've heard about correlation. You've heard about causality. Now, for those that are listening and not talking to their neighbors, we're going to hear about slope and an equation. Find an equation. Slope is equal to delta y over delta x, which is your change in y over the change in x, which is parentheses minus parentheses over parentheses minus parentheses. Now, this should be a review to y'all. Y'all been seeing slope and find an equation since Algebra 1. So if I give you 2 points, 2, 3, 4, and 5, which way do we read?
Left or right?
Unless you're from the Middle East. Allah Akbar Maslama. If you're from Middle East, you read right to left. If you're from around this area, you read left to right. X of 1, Y sub 1, X of 2, Y sub 2. So 5, 3, 4, 2, and that's going to equal 2 over 2. So the slope is equal to what? 1. Do you know if you walk up to me 10 years from now and ask me to calculate the slope of a line, I'm going to use these parentheses, and I've got several degrees. But students don't use those parentheses because it's beneath them to use those parentheses until I give them a fraction or a decimal or a negative, and then they get it wrong. So what am I trying to tell you as students? You should use the parentheses, guys. All right. Now find an equation. Y minus y sub 1 is equal to m times x minus x sub 1. And I'm going to use my x sub 1 and y sub 1, my 2 and 3. Y minus parentheses equals parentheses times x minus parentheses. And 1 goes here, 3 goes here, and 2 goes here. Y minus 3 is equal to x minus 2. Y is equal to x plus 1. Now, will you be tested on this? Yes. So make sure you can calculate the slope and you can find an equation. So let's do one with negatives. -2, -3. I'll tell you what, let me change it. -4, -6, -2, -2. All right, I want y'all to do that one. Find the equation and the slope. Calculate the slope and find an equation. All right, so x sub 1, y sub 1, x sub 2, y sub 2. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Negative 2 minus 6, negative 2 minus 4. So our slope is equal to what? 4 over what? 2, which is 2. And I guarantee you somebody in the class did not get 2. M is equal to 2. So now I'm going to use negative 2, negative 2. Why am I going to use negative 2 and negative 2? KISS method. What's the KISS method? Keep it simple. Use smaller numbers. Y minus parentheses equals parentheses times x minus parentheses. X of 1, y sub 1, 2 goes here. Negative 2, negative 2. Y minus 2 is equal to 2x plus 4. Y is equal to 2x plus 6.
Wouldn't it be y plus 2?
Yes, you're right. Thank you. The negative be 2y. Yeah, thank you. 2x plus 2. I made a mistake. And I have parentheses, and I still made a mistake. But we understand you don't need parentheses because you know more than I do.
Thanks.
I actually had a student come up to me. What was that?
What was that?
Was that the Unabomber back there?
The what?
I said, was that the Unabomber saying something?
What's the Unabomber?
Look it up. All right. Any questions on that? All right. How many people y'all got in there today?
2, 4, 6, 8, 10, 12, 14.
So who's missing?
Riley, but he's on.
Oh, yeah, she's right there. Okay. All right. Well, y'all have a good day. Y'all can work on 4.1 and 4.2, and I will see y'all Wednesday, okay?
Are those, is the homework still due the day it says?
Whatever Math Labs math says, I can't remember. Whatever it says. See y'all.
See ya.
Go home. I